Two closed vessels A and B of equal volume 8.21 liters are connected by a narrow tube of negligible volume with open valve. The left-hand side container is found to contain 3 moles CO2 and 2 moles of helium at 400 Kelvin. What is the partial pressure of helium in vessel B at 500 Kelvin? So our first condition is set at 400 Kelvin. We are having two containers connected by a negligible tube and the volume of both are equal. Let's call it V and V. And the temperature is 400 Kelvin. And in vessel 1, they are saying that there are 3 moles of CO2 and 2 moles of helium. Now we know that for both of these vessels, the volume, temperature, both of these quantities are the same. And since they are connected, right? Since they are connected, we can also say that basically the pressure throughout the region which is in contact should be the same, right? So the pressure here should be equal to the pressure here. Therefore, the pressure inside the valve will also be the same. So if all these three things are same, it implies that number of moles is also same. Therefore, in vessel B, initially there are 3 moles of CO2 and 2 moles of helium. So how many total number of moles of the gas do we have? 5 plus 5, that is 10 moles in total. Now we have condition number 2 when we are at 500 Kelvin. At 500 Kelvin, and the total volume that the gases are occupying is what? 8.21 into 2, counting for both the vessels. And the number of moles is 10. R is known. We have to find first what is the total pressure occupied. So using PV is equal to nRT, P is equal to N is 10, R is 8. We'll take R to be 0.082. So why? Because we have been given the volume in liters. So 10 into 0.082 into the temperature is 500 Kelvin now, divided by the volume is 2 times 8.21. So we have 3 zeros here, and due to these 2 zeros, this point would go here and it will be cancelled with 8.21. The 2 gets cancelled with this, and this comes out to be 25 atm. Okay, so this is the total pressure. So what will be the partial pressure of helium in vessel B? Now they are asking the partial pressure of helium in vessel B. Now we know that the pressure in vessel A will be equal to the pressure in vessel B. So the total pressure in vessel B will be 25 atm. Now the partial pressure of helium will be given by the mole fraction of helium times the total pressure. What is the mole fraction of helium in just the second volume? The number of moles of helium is 2 and the total number of moles is 5. Correct? 2 plus 3. That into the total pressure, which is 25. So this gets cancelled and we get the partial pressure of helium to be 10 atm. And can you tell what would the partial pressure of CO2 be? It will be the total pressure minus the partial pressure of helium, that is 25 minus 10, that is a 15 atm. So therefore our answer, which is 10 atm, is nowhere to be seen in the options, and therefore the answer becomes none of these.